Okay, we have been solving systems of equations using three different methods. We've been graphing, we've used substitution, and we've used elimination. So now what we're going to do is we're going to take a look at some examples where we have a word problem and we're going to have to set up our equations, and after setting up the system we have to decide how we want to solve it. Now you can use any method that you want, but some methods are going to be easier than others, and some equations will kind of lend themselves to certain methods. And for example, if you have y by itself, then substitution method may be the best way to approach that problem. So just depending on how your system looks, depends on how you may choose to solve it. So let's take a look at some examples.
In this problem, you will find a break-even point. A fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Step 1. Write a system of equations. Let x equal the number of hats sold. Let y equal the number of dollars of expense or income. What equations should you write? The break-even point is when income equals expenses. So write one equation for income and one equation for expenses. The expenses equal the cost of the hat material plus the cost of advertising. The designer's income equals the cost of each hat times the number of hats sold. Step 2. Choose a method. Use substitution since both equations are solved for y. Start with one equation. Substitute 12 5/10 x for y. Then subtract 5 5/10 x from each side. And divide each side by 7. Since x is the number of hats, the designer must sell 200 hats to break even. Now it's your turn.
Okay, here's your example, here's your problem. I have a puzzle expert in this problem, and it's also a break-even question. So you're going to design this one just like they did the last one for the fashion designer. Decide, same process, decide how much is it going to cost this puzzle expert to create the book, and how much will they make when they sell the book, so their expenses and their income. Now I'm going to go ahead and give you some answer choices to look at, but make sure you pause the video and go through, set up your two equations, and decide what method you want to choose in order to solve it, and determine how many copies they have to sell. Now hopefully you've paused the video and you've come back to check your answer. The correct answer to this one, and let me just say, it doesn't matter how you solve it, which method you use, you should get everyone will get the same answer. The correct answer is 720 books. Okay, again, it doesn't matter what method you use, everyone will get the same answer, 720. Now, the solution page, once it comes up, just yours may look different depending on the method that you decide to choose after you wrote your equations. The method that they chose was the substitution method, because just like in the example, both of the equations were solved for y. So it just kind of lent itself to setting up substitution. But you can see there how they substituted in 2x and then solved for x and got 720 books. Now we're going to take a look at another example. And this one deals with identifying constraints, which means there's numbers that we know we cannot use. There's values for X and Y that just are not reasonable and cannot work. And from that, we also determine viable solutions. Once you get your answer, does it make sense? Will it actually work? And even though I have a solution, some of you all end there and you're finished. But with word problems, oftentimes you have to go back and think, well, I have my solution, but is it valuable? Does it even work? And we're going to take a look at that here. So in this problem, we're at a local zoo and we have 2 water tanks in this elephant exhibit. The first tank right now has 50 gallons of water. So one thing you could do, some of you all are very visual, draw yourself a tank and mark it at 50. We have 50 gallons of water in this tank. And it's going to be filling up with water at a rate of 10 gallons per hour. So every hour, there's 10 more gallons of water being added to our tank. The second water tank that's in this elephant exhibit right now contains 29 gallons of water. So you could draw yourself a second tank and mark it a little bit lower than the first one and label that 29 gallons. And this one is going to be filling up 3 gallons per hour. So a lot less water going in the second tank each hour. What we want to know is, when will these 2 tanks have the same amount of water? Okay, they're both increasing at a certain rate. They both have water in them right now. We want to know, when will they have the same amount? Okay, so one thing that we have to think about first are our constraints. So my question to you is, what numbers can we not have? Okay, the 2 things we're talking about here are gallons of water and time, which is in hours. So what can we not have? Hopefully some of you are kind of thinking through this and you're coming up with, well, I can't have negative numbers. I can't have negative gallons and I can't have negative time. Those do not exist. My other question to you is, can you have 0? Could we have 0 gallons of water in our tank? And theoretically, yes, we can. Now, right now, we have at least 50 and 29, but we could have no water. We could also have no water going in. We could stop filling the tank up. So that would be 0 gallons per hour because we're not filling it up. And we could also have 0 time, which seems kind of odd, but what that represents is right before you start filling the tanks up, at 0 hours, right now, you have 50 and 29. Because then after that first hour, which would be hour 1, increasing in increments of 1, this one's going to go up by 3, and this one's going to go up by 10. So you can actually have 0 hours. That just means the starting point. Think about if you were running a race, your stopwatch says 0 because you haven't started yet. So now what we have to do is we've got to actually set up our equations. Now this is our think box here that we just discussed, how we've got to have time and gallons greater than or equal to 0. So if we have any negative numbers, this is not going to be a viable solution. All right, so here's the first step. You've got to write your equations. Again, the 2 things that we're talking about are the number of hours that it's taking us to fill the tanks and the number of gallons in the tank. Now, for our first tank, we have 50 gallons of water right now in that first tank. And to that 50 gallons, we're going to add 10 gallons of water every hour. Now, we have no idea how long we are running the water, which is why X represents our hours. So the 50 gallons plus 10 gallons per hour will equal how much water is in our tank. Okay, so for example, for 1 hour, that would be 10 times 1 plus 50, so there would be 60 gallons of water in the tank. Tank 2 is designed the same way, but it only has 29 gallons of water in it to start with. And we're going to add to that 29 3 gallons every hour. That's our rate, 3 gallons every hour. The hours are exactly the same. We're going to turn the water on the same time, and so the hours will increase 1, 2, 3, 4, the same for each equation. And once we stop the water, or at a certain stopping point for time, we want to know how many gallons of water is in our tank. Now, the method that they have chosen to use here is substitution again, because they're both solved for y. So substitution is just a lot easier. They rewrote the second equation, y equals 3x plus 29, and then they just plugged in what y equals from the first equation, which was just our 10x plus 50. That's what y equals. So they plugged that in here. And then they just start solving this equation for x. So the first thing they did was subtract 3x from each side. So if you take 3x from here, you're just left with 29. If you take 3x from here, then you're just left with 7x. They subtracted 50 from both sides. So notice you're subtracting 50 from a positive 29, so you are going to wind up with a negative number here. And then you should know how to finish that out. Divide each side by 7. So we get x is negative 3. We'll take a look at this. X, if you go back up to step 1 when we identified our variable, x represents the number of hours. And we're saying that after negative 3 hours, our tanks should have the same amount of water. Well, if I substitute that negative 3 in, hopefully you're kind of thinking that this is not going to be possible, but let's go ahead and plug the negative 3 in. We plug negative 3 in for the first equation, and we multiply negative 3 times 10, and then we add the 50. That's going to give us 20. So this is the solution to our system, negative 320, and in the past we would be finished. That would be our answer. But what we have to think about is this is not a viable solution because it's not possible to have negative 3 hours. So what that means is that the tanks never have the same amount of water. Now, some of you all may be thinking, well, if we went backwards in time, you know, if we went, say we started at noon and we had 50 and 29 gallons, maybe 3 hours prior to that, they had the same amount of water. You could possibly come up with an argument for that, but what we're discussing here is at our starting point of 50 and 29, moving from that point forwards, will they ever have the same amount of water? And they won't. So even though you have a solution, it is not a viable solution. So therefore, you can conclude that your tanks are never going to have the same amount of water. So now it's your turn. I want you to take a look at this example. Again, this is similar to the last one, except this time the two tanks that you have are leaking. So the first tank contains 10 gallons of water, and it's leaking 2 gallons every hour. So it's not adding water like we were in the last one. We're actually subtracting water. We're losing water in this problem. And the second tank is starting out at 6 gallons. And it's also leaking, but it's leaking at a rate of 4 gallons per hour. So decide what your constraints are, what type of numbers can you not have, and then also decide if your solution is going to be viable. So you've got to set up your equations, and you've got to solve them for x. So here's your answer choices, 2, 4, 6, or that it's not a viable solution. So you've got to decide that once you reach your final answer. Now hopefully you pause the video and you're coming back to check your answer. The correct answer is that this is not viable. The answer that you get does not have a viable solution. These are the two equations you should have set up. 2x plus y equals 10 and 4x plus y equals 6. Now the reason they set the equations up this way is so that we do have addition. And I will say that some of you all may have taken your equations and set this up as y equals 10 minus 2x because you're subtracting out that constant rate because the water's leaking. And that's also the same. If you were to solve this equation for y, you would get 10 minus 2x. The way they designed this is actually using standard form so they could set this up using elimination. Now, if you wrote your equations a different way, you may have chosen a different method, and that's perfectly fine. But either way, you should have gotten down to the point where x is negative 2 and y is 14. So that's where you should have reached no matter what method you choose. Now, even though that is a solution to your system, it's not viable because it's not possible, again, to have negative time. So the tanks will never have the same amount of water until, obviously, you're losing water until they completely run out. But cannot have negative time, therefore your solution is not viable.